Good morning, good morning, good morning. Hello, hello. Hope you're having a great Monday so far. Quadabot, hello, good morning. I am super happy that I was able to get this get the simulation working yesterday to the point where it actually looks pretty good. Now it's not finished. There's a few things left to do for it to make it actually like look like the appropriate flocking simulation, but still it's kind of fun to watch it fly around the screen and do its thing. I did notice that if I get to like a little bit over 100 of the Boids, it doesn't work too well in dev mode. In release mode, it's fine. It can handle 250 just fine. And there's a lot of things we can do to make it handle a lot more Boids. We could use some kind of like grid system so it only checks Boids near it instead of having to like loop through over and over and over again. But for right now, for like the purpose that the flocking simulator is using, which was to build the first version, the MVP of the ECS system, I think it's working really well so far. So what are we doing today? Today we are going to be continuing on with the flocking Rust simulator, and now we're gonna kind of make it feature complete for the simulator part. Oh, Raven Legend redeemed Pet the Cat. Also, hello, Raven Legend. Is Raven Legend here? Is the cat here? Is Zilby here? Zilby. Kitty Cat's not here. If Zilby comes down, we will do an immediate Pet the Cat. How about that? It has been a while. Things are going pretty well. I don't know if you saw the simulation. We've got this up and running. We still need to so the thing that we're going to be doing today is making them attracted to each other, so they don't just get attracted to the same direction that they're going. They're also trying to move towards each other, which is gonna be really nice. Okay, so what are we gonna do? How are we gonna do it? I think for this, we're gonna start a new system. You know, in this case, the system's gonna be pretty similar to the previous one. So I wonder if there's gonna be like utility functions that we can create. I'm not sure. It's probably not going to avoid. It's probably gonna not trip the rule of 3 because it's only gonna be the second time we're doing this. So let's see how it goes. This is gonna be the attraction system. So pub function. Oh, you gotta go, Raven Legend. Well, thank you so much for stopping by. I'm sorry you didn't get to see Zilby this morning, but maybe I'll post something with Zilby on the Discord later. Have a great rest of your day. Okay, so pub function, this is going to be the attraction system. And we're going to take in a world, just a mute world. And I kind of forgot if that wants to work. Pub mod attraction. Oh, wrong number of tech arguments. It's not world that we need. What was the new one? It's the world wrapper. Okay, so you've got you now. The idea is we're going to immediately just call this in the main library in update. So we have the avoidance, we have alignment, and then we have attraction. Okay, so how does attraction work? Attraction let's say we have we have a few of these voids around, and if we're looking at this one right here, so it'd be these two is what it sees. It notices that the average location for these two is right here. So it's going to be attracted towards that location. So that way, everybody within their sight range is going to be attracted to something close to each other. Which that would be pretty cool. Now, something that I'm noticing is sight range is probably should be a resource, because we're using this in a couple, like all three of these systems, and I think that if we have the sight range be different from everything, then that might actually like cause weird little physics bugs, mostly like when we're trying to like tune it all. So let's go ahead and make that just a single thing. We're gonna throw that in here. So I guess in resource names we need sight range. And we also need an F32 in resource here, which we don't have. I am Hardliner. Hello, how are you doing? I'm doing pretty good too. It's just starting out, so I'm looking forward to like basically getting the simulation to look correct today. That's if we're able to get it there. But I have faith. And I don't remember if you've seen what it looks like so far. I think it works right now. This is where we're at right now. So we're trying to make it so that they're all attracted to each other as they're moving through here, which is going to be pretty cool. I think that's going to be the last thing. Let's see. So cast the F32 in our main library. Now we're going to world.add resource. Okay, so the name of the resource is gonna be names. This is the site range. And the resource. And I think we want to do 50.0. And so now what that means is in each of our systems, we can now grab this resource out. And then use it there instead of like the hard-coded number that we had previously. I am Hardliner. You started a project today at the wrong end again. You bought the domain first. I've been guilty of that many times myself. And then the domain usually sits there idle for like a year. And then I'm like, well, do I really want to pay for it again? And then I usually let it go. All right, where's my systems? Here's my systems. Okay, so in alignment, we see, where is it? Here is my site range here. The alternative is having a bad domain. I mean, yes, that's true. That's true. If we're all made of money, we could just buy all the domains around the idea, so we capture like any pivots that we're gonna do too. Okay, so I want to replace this with something like a site range variable. Just buy a wildcard for star.io. Oh yeah, just buy IO like from whoever owns it. That'll be fine. We're made of infinite money, correct? Okay, so I need to get the resource out of here. It's in this function. I might as well just query it inside. Let's see, get number indexes, my location. I think I want to query it once at the start of this function here. So we can do here. This is going to be a, we have to do the borrowed. Be right back. You're buying IO. Okay, let's see. This is going to be our site, our borrowed site range. Let's see, what is it? Oh, get resource, and then the name of the resource. So it's going to be reference to source names. Okay, so that gives us this RC ref cell. So I'm going to then borrow it. Okay, that gives me the resource. I don't think I can deref it here. Oh, I can. Okay. I can deref that. Then I don't have to have this be a borrowed site range. It is the site range. It's just it's a reference to the resource, and then I can let's see. Deref, I can just cast F32. There we go, and that gives us, not the deref, I can just cast the F32. That gives me the site range right here. Wait, no, I can't do this, can I? Because it needs to be borrowed first and it's gonna drop too early? Maybe? Or maybe it's fine. Okay, so we have the site range. Now what I want is in the nearby indexes, I wanna pass in the site range. It's gonna be an F32 in here, and you're gonna replace site range here. which means where you're set up, site range gets passed in. Okay. So we've got that. And that's it here. So we're done here.
Little ditties, tiny things.
We don't need deref. Okay, so what's next? So handling the edges system, we probably can use the sight range for this too, which is how close to the edge can we see it? And that's when we start turning away. I kind of like that. So instead of like having this margin here, we're gonna have our sight range. It's equal to world.query1. This is gonna be the Okay, so then we're going to borrow this. Then we're going to cast. Okay, so you're rec. Oh, I don't want to query. I don't want to query. I want to get the resource. Okay, so then I borrow, and then I'm going to cast as an F32. Okay, so that gives me the sight range here. And then the margin is going to be the sight range. Okay, so that should make you all happy. All right. Back to the main library. The avoidance system, we just did that. The alignment system, we did. Wait a second.
There's only so many different things you can do. Yeah, you don't want to push it. Don't be blatant about it. Be subtle.
Oh, hold on. Avoidance system. Sight range is just hard coded in here. We need to fix that. So, sight range equals that. Okay, so that should be fine there. Get resource. What? You didn't come in?
If you listen enough, you start to pick up on the enormous amount of repetitive, the same.
All right, well that's fine too. If that's how you want it, Rest Analyzer. Okay, then we have alignment system. Here's our sight range that we got. Attraction system, we're about to write that. And the update location system, we don't have to care about that one bit. Okay, so I kind of want to double check the numbers here now. So if we just do the handle arena edges, let's see how this feels on its own. All right, it still actually feels really good the way that it is right now. So then we have the avoidance where they are avoiding each other. Which is nice. Okay, they're avoiding each other still, and that's looking pretty good. Excellent. Then the alignment system. The animation is still mesmerizing to look like. I agree with that. Also, good morning, Epic Blarg. Did I not? Oh, I brought it together. I feel like they're kind of aligning together, but also not really. Not like they used to be. So I'm wondering if the range for that. I wonder if because like the avoidance system is causing them to avoid each other too much. But I also wonder if this will be fixed in the alignment system, which makes them go towards each other too. So it's like constantly trying to go towards and away from each other. But I also wonder if like this entire sight range is not the best idea. I wonder if I want to come into alignment system and sort of override a little bit, where I say like I want my sight range to be this F32, but I want like to add, I don't know, like times 1.25, just to make it a little bit stronger of an alignment. Yeah, okay, so they're aligning together a little bit more. So maybe I can do little overrides like this inside the systems. That might be a better way to do it. So we have a generic sight range. Okay, so now given that, let's now do attraction. Okay, so we have our world wrapper. We also want to turn you on again. What's the first thing that we want? Well, we know we need that sight range, so let's go ahead and get it. And I probably want to do like the exact same thing that the other one did and have like a little bit of an override of like 1.25. That probably would work out the best. And then we can have like the other one multiplied by like a 0.75 or something like that. All right, so sight range is world.get source name sight range. They're gonna borrow this. We're gonna cast as an F32, and then we're gonna multiply it by 1.25. Okay, what else do we need here? We need all the locations, and we need the ability to clone the locations so we can find our own. But then we can loop through everyone else's too. That locations. This is gonna be the wrapped locations. And instead of resource names, this is component location. And I'm not going to do a borrow at this point in time because I'm going to clone the wrapped locations whenever I need it in order to get inside the RC to get to the ref style, and then we can borrow from there. What else do we need? So we have all the locations. I'm going to need that twice, most likely. One to get our own location, like for each location, and then to go through all of the other locations. I also need... We're going to get the average of everyone's locations, and then create a force towards there. So I just need accelerations then. This one we can borrow mutes, and we're good to go there. All right, I think we're ready to start our first loop. So we're going to handle each location. That's going to be a wrapped locations. We're going to clone it. That gives us another RC, but now we can borrow it. Then we can iter it and enumerate it, and then for each it. And that now gives us a function that we can have here. Now I wonder if I can create this function as like in another variable, which I think that I can here, but I don't think I can do that down here. I don't think I can just have like a let in here, can I? So I can't just do like let handle location equals something like that. Right? No, you need to be inside of something. Although I can have it be returned. I can have like a function that generates this. I don't think I can do like a function handle location. I think I can do that, can I? Let's see. Function is expected to take a single two tuples an argument. Oh, wait, I can. Okay. That takes 0 arguments. So a single two tuple as an argument. So you take, we're gonna get the index and the location, which is a usize and a, what are you? Something else. Okay, this reference to a BB ECS component. So you take in a reference to component. Like that. Okay. Hey, this works. Okay, excellent. So this is going to make it a little bit cleaner. It's just moving things around, but it's making things not move to the right quite so much. Chantilly, hello, happy Monday. All right, so for each of these locations, the first thing that I want to do is, well, okay, let's see. What's the first thing that I really want to do? I need to get all of the other locations, get their velocity, get their average positions, their average location. So the site around me. So I need to loop through all of the other locations and then get their probably, okay, I need to I can clone them for right now. That's decently cheap, and I don't have to worry about it too much. So I'm going to get the other locations. So we're gonna do let it can be like all the other locations, but I think this might be better to just like in one go I can get like locations near me. voids near me is equal to, and then some like function which we can call, which is get voids near me. We know we're gonna have to pass in the index, so we know who is not ours. And we know we're gonna have to pass in the wrapped locations. We can clone that at this point in time. So we can just do the wrapped locations. Oh, I can't do that because they're not here. Ooh, that's a problem. I was able to do that before, but now I don't have a way to pass that in. I might, oh, okay. What I might want to do is this, which is do the location information like that, and then we want to call handle location, pass in location, the information, and then also pass in the wrapped locations dot clone here. So then you're gonna yell because you need to take in this. This is gonna be other locations, which is a type. It's a ref, which is a vec of component. Yeah, okay, that makes that happy. Then we get here, and we don't have a get voids near me, so that's fine. We understand that. And then these are the other locations that we now need to pass in there. And oh, cannot. You are a ref. Do I need to pull you in? Oh, it's an RC. I can borrow you right here too. That does it. All right, so function get voids near me. We know we're gonna take in the index, which is a usize. We're also gonna take in the other locations, which is this. And we're gonna return a vec of probably like a point. Right, okay, so you're just yelling at me because I'm not actually returning it yet. Let's go ahead and just return an empty vector for right now at the end. That'll make you happy. All right, so we need to loop through the other locations. We also need to get the site range, don't we? So we need to pass in, we also need the site range, which we know is an F32. So in here, we need the site range. F32 and pass you in here. Which means we also need to pass you in right here. Okay, so that makes you all happy now. Okay, now because I have the site range, we should be able to get like the length between the two different points. Do we have like a distance to on point? Well, okay. First of all, I wonder if I want to. I'm thinking we can do this all with the fold function, I think is what it was. So we're gonna do a other locations. Is this reca? So we're gonna do an iter. Then we're gonna fold. Our initial value is gonna be an empty vector. And then we're gonna have our function. So what I want to do this, I think I'm just gonna call this like fold into, oh, let's see, what is this? This is gonna be fold into, maybe I'll just do this right. The closure here. So what am I getting in? I'm getting in like this initial vector here, which is the, this is like all of the Boids near me. So Boids near me. Also getting in the next location, which is really the other location. Okay, so Boids near me, you are probably gonna need to be mutable so I can add to you. We know we're gonna return the Boids near me, so I can just do that right now at the end. Oh, come on. I'll tell I that. Please. We also know that if we don't, do we not have the index? We don't have the index. We need to enumerate this. The item here is other index, other location, and there we go. Okay. Do I have some background in functional programming? Self-taught. My background was, let's see. As a sysadmin, I learned procedural programming with shell scripting, and with a little bit of C code, like C, Python, that kind of stuff, with just sort of like automating a bunch of tools. Then I went into web development and learned, classic object-oriented programming. I met up with like a bunch of mentors who were sort of also getting into functional programming at the same time, and that's what really introduced me and got me into it as well. So like I have never got into like the mathematical side of functional programming. It's really just like, hey, like here's the general idea of functional programming. Let's just go into that. So that's why. And that I guess that's the answer of like what my background in functional programming is not very much. In your experience, people who grab for fold are experienced in functional programming languages. Well, so I have a lot of experience in JavaScript, and I love the array methods like map, for each, filter, and of course reduce. And reduce here reminds me a lot of fold, which is I'm reducing an entire array, or in this case a vector, into a single thing. And that's kind of what I'm doing here. So that's, to me, fold is very familiar to me already. So I guess like, yeah, I don't have a background in it, but I also like am not scared of it, if that makes sense. And I would love for more people to sort of like dip their toes in, because I don't think you need to go very far into functional programming to get huge benefits from it. All right, so our first thing is we want to make sure that if it's if our index is equal to other index, then we want to return the Boids near me. Else, we want to do the rest of this, which will include Boids near me here. Yes, I know you have identical blocks. Don't worry, we'll be fixing that very shortly. Okay, so now that we know that we're not looking at ourselves, we're looking at somebody, some other location here. We need to get the distance between our location and the other location. So we have, we don't have our location, do we? Like, we have other locations. Now we have our index though, and we have all locations. I kind of want to like change this to all locations. This can maybe be like all locations too. So then we can shadow this. Or maybe I can even just do like, this is wrapped all locations. All locations is now going to be equal to the wrapped all locations dot cast point. Okay. So now I have a reference to point here. Okay, so now I have all locations here. I can now get my location. So let our location is equal to all locations of index. Wait a second. That's going through each one. All locations iter. I can actually get that out right here. All locations. I want you to be my location. So I need to, you're already a vector, so index, that gives me this component. We're gonna cast point. Okay, there we go. Now we have my location here. So we do this once. We get all the locations together. We make sure that we're not looking at our specific location. So we can do U right here. At this point in time, we need to get the distance between our location and this other location. So I want to go take a look at this other point. So let's go look in here. What methods do we have? We have the length of the point. Okay, we have distance too. So the distance between one point and the other. Okay, that's perfect. And we have our site range. So if my location dot distance to we're iterating through, okay, this is not all locations anymore. This is really just a wrapped other location. Other location equals the wrapped other location cast point. Okay, so the other location. So if that is less than or equal to the site range, then I want to take the Boids near me and push in the, I guess like it's going to be the other location. And that I'm hoping should copy it, clone it, mismatch types. Oh, fine. I will destructure you or dereference you. That will auto copy it because I have copy on here. And then at the end of this fold, we get, actually we get this item. So that might be fine. Okay, so we get the Boids near me. So now we have these. What's next? I now need to average out. So like let average location other Boids. And so then this is going to be calculate average locations, and we're going to pass in the Boids near me. And we can give ownership of this. All right, so what are we getting? We're going to be getting this vector of points. So this is going to be all the Boids, which is a vec point. And we're expecting, so an average location is just going to be a single point. That's all we're going to be returning, which means that's another fold that we can do here. And now, is that true? I think that it is. So it's a two-step process. To get the average of anything, we need to add up everything and then divide by the scalar of like the length of this. And I think we have a divide for this vec, for this point, don't we? Yeah, we have a div here, so we can do that. So we're gonna do first let average location is equal to voids dot iter dot, I don't need to enumerate anymore. We can just do another fold. This is going to be a point new, and we're going to be adding to this. And then we're going to have our function, which is going to be our average location. And then the other thing is going to be the next location. So just location. All right. What do we care about here? So you need to be immutable, so we can add to you. Then for every single one of these, location is gonna, I mean, I wonder if I could do some. That would actually be really cool if I could. I don't know if I can. I want to try it. If I put an iterator and then I do some. Yes, I know. I'm not returning you. Type annotations needed. Okay, so you're going to be a point. The trait bound point. Consider iter sum for point is not satisfied. Okay, so standard iter sum for point. Okay, so I think what we can do is come here and implement that here. So implement sum of type point, I think. And then it really is going to be self here. Is that true? Can I do that? Point? I don't think I can. I think I have to do point. Or point. Okay, so function sum, I iterator, item is going to be a point. Iterator I returns a self. How are we going to do this? Okay, so iter is I, so that's going to be all of the points, like as it hits. I think it's gonna work. We're gonna find out really quickly. Okay, so how does this work? Because I could just have iterator I coming in here. Does that mean I can just do like a fold? Is there an example? Let's go to the actual documentation. Oh, I don't have it anymore. Okay, so it generates self from the elements by summing up the items. Okay, so iterator is going to be iterator over each of the items. So what I can probably do is say rename you, I think, your points. I want to say like let you point like summed points. We can do fold here. That actually might work. Do points dot fold. Our initial is going to be a point new. So actually, in this case, I can do a self new 0 0 0. We're going to have our function. So this is going to be the summed point, and then we're also going to have the next point. You're going to be mutable. We're going to say the summed point dot add point, like that. So add that together and then return summed point. Mismatch type expected, a reference point, found structure. Okay, yes, reference to you. Okay. And then we return this. Okay, so does that work? Can I now do sum? The trait bound components point iterator over a sum of a reference to point is not satisfied. I need to do a clone on these or an into iterator. Okay, so it needs to clone over it. It's just not the best memory wise, but it makes this code look so much better. So this just, okay, so this gives me the average locations, which is this point. Okay, that's awesome. And then I need to just return average location divided by the Boids.length. Use borrow a move value Boids. Wait, okay. Actually, I don't have to do this. I could extract out the length here. So let voids count is equal to voids.length, and then we'll divide by voids count. Can you implement the sum over reference to point? Oh, that's a good question. I wonder if I can. So if I do this, we're just going to go into iterator again. You're yelling at me, so let's see if I can sum or a reference to point. So then this will be a reference to point there, I think. Method not compatible with trait, expected reference, a reference to point, found reference, static components point point. Wait. Reference? Oh, it has an incompatible type for trait. Expected. No, okay, so the trait itself can't handle a reference. That's our problem. The trait itself can't handle a reference. I think I ran into that with some of the other ones too. It would be nice, like, so I could just like implement some myself. But using the traits is really nice. Okay, so we have to clone. We have to do an into here. We get our Boids count. Okay, so this works. So we can now calculate our average locations. Okay, so we now have our average locations here. We have that point. This is the beginning of our force. We also have to, okay, so we have to create our force now, so that our force is going to be equal to, and I always forget, is it you or me that I do the difference of? So let's go to avoidance. I think in this case, it's going to be the opposite of what I do here, which is, I think it's going to be my location minus the other location now, this time. We have our location, so it's going to be location minus the average location of other Boids. Okay. And you need to be dereferenced. Okay, fine. Only one of them is dereferenced. Cannot subtract from. Oh wait, my location is. That's actually. So we have this as a component here. What I can do is take our location. Oh, yeah. Okay, fine. That location is location dot cast point. Yeah, cast point. That. Okay, so then we can dereference this location with that minus that. That gives us this force. I want to then take the force. Okay, we're gonna do force dot normalize. And then we want like the speed. Like what are we gonna like move it to? So force dot multiply. Multiply scalar. What are you? You're, oh, right, because like when I do this, it no longer knows what it is, which kind of sucks. It's like multiply scalar with like 0 dot, I don't know, 1. We should update this to be a resource too. I don't think I can do that. Okay, yeah. See, this works. The problem is that Rust Analyzer has sort of forgotten and like doesn't know what this is. Even though it actually is and the compiler knows it is, this is going to compile just fine. And Rust Analyzer knows it's going to compile, it just no longer knows what type it is. Kind of sucks. But okay, so we force normalize this. At this point in time, now I can take the accelerations. We need to, okay, so we have the index for this. We can now, we've borrowed this. Okay, so we can do accelerations. Of index. And we want to plus equals to the force. Right. Accelerations is here, so we need to pass in accelerations here. Peyton Rules is raiding with a party of 2. Hello, Peyton Rules. How was your stream? Let's do the Get the Streamer game, since we're celebrating getting raided with Peyton Rules. Peyton, I think I saw that you were working with, was it resources or something in Godot? I don't fully remember. Like it was now a while ago that I sort of saw your going live notification. I wonder if to wait until, oh, not Godot today. Ah, trying to read the message. Working with a sprite sheet but in WebAssembly. Oh right, because you're making your WebAssembly game. I forgot about that. Oh, that's pretty cool. Sprite sheets. Are you using like CSS to like handle all that? Oh, okay. Halfway through in 2 more lives, I can do this. You built one in Texture Packer and you're trying to use JSON. Oh, that's interesting. Can't believe I didn't get hit there. But are you gonna use like oh, I guess like JSON to like, and then probably JavaScript to cut them up like live in runtime? Oh no, no! I was so close. I was so close. Epic Blarg with 65 points. You got all the hits that time. Yeah, exactly. Nice. Nice. Spreadsheets are interesting and fun. The swords are OP. The swords aren't too bad until you start mixing them with the fire and the snakes. Then suddenly they get like really they get pretty pretty OP, yeah. Yeah, see, I can imagine CSS being good for the sprite sheets because you can say, I want this image, but like also give me like a sub image over here and then translate it over. But you can use JavaScript to set CSS rules too. So you can be like a combination of both. All right, what were we doing here? Right, we are passing in the accelerations. So we need to pass in U to accelerations here. That means we also need accelerations into handle location here. You are going to be a ref mute. So pull you in. You're going to be a vector of component. So then we need to pull in and get accelerations is equal to accelerations dot borrow mute. Okay, now I can accelerations of index plus equals this force, maybe. So, oh, right. Okay, so once I have that, okay. So we need to maybe do let acceleration equals accelerations of index, and then we're gonna cast to a mutable point. Then we can do acceleration plus equals the force. Let's see. All right, I think this will work. Oh no, we have an error up here. Where's my error? Here it is. Accelerations, mismatched types, expected, struct, standard, cell, ref mute. Founded mutable reference. Wait, so replications for each handle location. Oh, and that's for each. Oh, that's a problem. Because that means it wants to be like multiple at a time. I was trying to be clever by putting these all in different functions, but now let's see, what have we got here? We got a ref mute that's gonna be going in here. I'm gonna have multiple ref mutes. This is not gonna be happy. Now found mutable reference. Of this. Right, I forgot there's the mute. So what I can do is your mutable reference. You're still upset. Okay, expected this mute here, mute. Oh, and then it's like this weird thing like that. Mismatch types. So expected mutable reference, that found mutable reference. Okay, let's just do this entire thing. Cannot index into a value of type mute. RC. Wait, so did I not borrow this? Accelerations. I thought I borrowed you. So now you're this RC, so I need to borrow you again to get into the ref cell? Oh, wait. I borrowed you already. Hold on. Why do I need to borrow you again? Okay. So accelerations is this RC of ref cell. We query. So hold on. What do I have here? We have this RC of ref cell. If I borrow mute, it's still an RC of ref cell. Why are you doing that? I don't want to borrow the RC. I want to kind of like deref and then borrow mute. There we go. That gives us the ref mute. That gives us the ref mute. So then here I want to be back to this. You're going to be a ref mute of a vector of a component. Five functions. 3, 4, 1, 2, 3. Oh. Okay. Now what? Cannot move out. Right. Okay. So this is the problem. Is it's attempting to move out of here. So this is kind of like what I was afraid of. So I need to not do this here. Unfortunately, so I what the heck? I don't know what my keyboard just did. Hold on. If I do Control X. Oh, wow. Okay. Zilby. Oh, I did it again. Stop. Zilby. What did you do to my keyboard? I'm assuming it's Zilby. Like none of this looks normal. So this keyboard includes a macro function ability. So I'm guessing that Zilby stepped on my keyboard at some point in time and like recorded a macro, which was Control X. Yeah, I did it again instead of Control Z. Stop. Hey, stop. No. You're not done yet? No, stop. Don't save. Control Z. Don't accidentally move over and press Control X. I have to learn that now. Okay, so I removed all that. Okay, I just removed it. Gonna remove the accelerations. Gonna remove you from here. We're gonna do. We'll grab them here. accelerations is going to be equal to. All right, so this is going to be a thing. We don't have the world here either. Okay, so I can pass on a reference to the world. That'll be fine. So world dot query one component names acceleration. Okay, so that's going to give us that. Then we want to deref to get to the ref cell, then borrow mute to get into the ref mute, and then we're fine there. We're happy at that point. You're going to have to be mutable. Then we get down here, we have this acceleration, so we don't need this entire thing. We're going to do accelerations of index times equals the force. And you need to be, oh right, cast muted. So this gives us a vector of all of them. We're going to cast point mute times equals to force, and then we have to, I think, deref mute. Oh, let's see. Force. Do I have multiply? I don't know if I have. Oh wait, it's not multiply, it's add. It's add assign. I just want to add it. I don't want to multiply it. Okay, I think that'll work. So save you. Attraction should be working now. So we now should see them attract to each other. Let's see if all that works. That's the get the streamer game. Nope. You. No, okay, cool. So that's super happy. Oh, wait, I know what it is. It's this problem here. We can only do this. We can only do this if we have a point to do. So I think I need to have this return an option point. And then this is, it's gonna be, wait, what did I do? Now tab is going up there. I can't, what? Okay. If we already have this length, so if the Boids count is equal to 0, then we want to return none. Else return a sum of this. Now coming up here, we're gonna handle you. So okay, so that mute force equals, this has to be an if let for you. We can do this right here. So if let sum force, we got to be a mute force equal to you. No, it's this here. Hold on. If let sum, I don't know if you need mutable. That equals you. And then everyone else into the pool. You only happen if there are Boids near me. That entire divide by zero math problem, that's kind of an issue. All right, so it kind of looks like it's sort of working, but I think the site range, we need to do this as, let's see, we're doing this as times 1.25 by 5. Like they are moving towards each other, but they're also moving away from each other, maybe a little bit too strongly. So let's do avoidance. And for this sight range, kind of want to then multiply by 0.5 to now make it like, it takes them longer to like see, hey, you're close to each other. Okay. It's kind of working. What else do I need to do for this? Is your turn a little bit too strong? Is your turn a little bit too strong? Create an avoidance force. What if I do this as like 0.1? So when I'm avoiding each other, it's not quite as strongly. And maybe also alignment needs to be like 1.5. And where's my... Oh, there's that number too. At this point in time, it's like tweaking the numbers to get them right. Okay, so we're getting closer. I think with avoidance, I need you to be like weaker. 0.05, half the force. I can have it be I can also like, okay, so we're getting closer. Like there's these bigger gaps as they're kind of starting to flock together, but not completely. With avoidance, maybe like 0.25. It's like things are starting to happen and it's looking pretty cool. I wonder if my force to attract needs to be stronger. My attraction force. I wonder if you need to be stronger. It's like multiply scalar by like 0.25. Or if I need to like see you from even farther away. It's like go closer together, but like, oh no, go farther apart. It's very fascinating. Like what's happening now. Let's say if I just do like 2.0. It's like I see you from very far away and I come closer to you. This project made you Google, do birds ever collide with each other? And it turns out they don't. Scientists figure out how they only turn to the right to avoid collisions. Really? Really? They only turn to the right to avoid collisions. You know, I can use that. So create the collision force. Hold on. Acceleration add, create the collision force. I would take in this distance. If the distance at length is less than a sight range. If, let's say I don't do this. I don't take in anything whatsoever, but we're going to create a point. So, what I'm going to do, what I do need is my own. I need my own velocity. Oh, I don't think I have that. I don't have my own velocity. Okay, so I'm gonna borrow mute out of you. Then we have in here, okay, so create the avoidance force. I need the velocities of index, then to cast point, just to cast a point. So now you're gonna yell at me saying, let's see. My velocity is going to be a reference to a point. Like that. Okay, so you're happy. Then I want to say let mute force is going to be equals to a velocity dot to perpendicular right. I don't need to multiply the scalar to reverse it. I'm just going to normalize that and then multiply the scalar by this, by like 0.1, let's say. And suddenly we're moving to the right. Now everyone only moves to the right to avoid. The attraction is a little bit weird. Okay, so how do I want this to make this work? For the avoidance system, like this is like a very small number now. Let's see. I feel like they're still avoiding each other by like a huge range, like 0.025 seems like too small of a number. Oh, is my attraction now too high? My attraction might be just way, way, way too high. Let's say I have this as like 1 point, like just nothing. I just have you as the F-32. Okay. Interesting. So we're starting to get some flocking behavior here, and the always turning to the right is really fascinating. Like, it's working. Yeah, look at this. It's actually working. Like, I could still tweak some numbers to make some little minor differences, but this is looking pretty good. I think sometimes they might still be actually like seeing each other a little bit too far. So what I can come in here and do is say in this resource for the sight range, I can say like, you're actually 25 pixels. You can only see 25 pixels away. Only turning to the right, finding only applied to head-on avoidance. Same deal as weight staff. Oh, only turning to the right was only head-on. Oh, interesting. Okay. Then this may not, I don't have the logic for head-on. I would have to like look at the other velocities and see if they're coming towards me or not. That would make sense though. That being said, look, everything's sort of coming together. Apply directly to the forehead. Yes. This might be a little bit too close, like too small of a number now. Like they're slowly coming together. Attraction might be fine. Avoidance is like the super tiny number. Can probably bump you up to like that, and attraction can be then times 1.25. I could probably like play with these numbers all day to get like the exact right like combination that I want it to be. But the general idea is we've got a really cool simulation going here. So there's some other things that I want to do to like make it even better. I want to swap the circles out with triangles that point in the direction that they're moving. I think that'll be a lot of fun. I could also reduce the like I don't know if I want to or if I need to like change the drawing that I'm doing. I would love to test this on a Raspberry Pi to see like how many voids I can get at the same time. You should be able to use a simple dot product to determine if they're heading for a head-on collision. Use some linear algebra for that. Because I guess if I have the velocities of them and I have velocities of me, the dot product would be what? It would be almost, well, it wouldn't be exactly the opposite. Because like they could come in as angles to each other too. But dot is where I take like x times y, y times y of the 2 points, right? That's dot. Or am I mistaking like what dot is? I guess I'm not completely sure what that would give me. But anyways, we've got some cool steering mechanisms. We've got some cool sort of like almost flocking. Felt like I had the flocking a little bit better. Yeah, the dot product can help you tell if the two vectors are heading towards from each other on a -1 to 1 scale. Does dot product, does that create just a single scalar? Or is dot product return like the same hash with like an X and Y? It's a scalar. Okay, so I was thinking dot was just like X times Y, Y times Y. I guess like then they somehow like add them together to become just a single number. I'd have to look up how dot works. I used to know what it was a long time ago. I forgot. Avoidance. Wait, I didn't save this. It's like avoidance works. I think I kind of liked it when this was 50 again. It's still. And like we have essentially 1.25 here. Avoidance is like maybe 0.75, and then 0.5. Not sure. Like lots of little tweaks that could be done, and I could probably just spend all day tweaking this to make it look really good. But now, like, these are all moving together. They kind of move apart when too many of them get close. They move to the right to avoid each other. But besides that, I mean, I like it. All right, so what's the plan? Tomorrow, while I have like this working, we can still continue to tweak on the numbers, but I want to change the circles out to triangles to make them look like even cooler, pointing in the directions they're moving, so we can see like the appropriate like waviness as we see. They sometimes split up to create smaller flocks, just as in real life. Yeah, that's actually really cool too. I sort of like didn't think about this. They're a little bit far away from each other, but I think that's where in avoidance, this can be like, I don't know, like a really, really small number. I'm not sure like what I want it to be. That way they avoid each other, but like see each other from farther away to get attracted. Yeah, I don't know. Anyways, that's gonna be